Maybe we can wait for a few more minutes for the students to join.
Good evening, sir. You can start by 6:10, I think.
Okay, sure. I will start in 2 minutes.
Yeah, thank you.
Okay, maybe we can start now. So let me share my screen. Okay. I hope my screen is visible now,
Yes, sir.
everyone.
It is visible.
Okay, so let me start. Okay, in today's session, we will be seeing about face recognition, and it is divided into like the whole presentation is actually divided into a few parts. Where in first we will see about face detection and face recognition, and then we will see about face landmarks, by which you can actually see how Instagram, Snapchat, or ShareChat and other applications which are actually putting some filters on your face, how they are doing it. Okay, so maybe I think you people have like gone through my introduction and other things. So I will directly start with the today's content. So today we will be actually like seeing some introduction about like creating a machine learning system, and also about face recognition, and then we will see live coding examples for face detection and face recognition. And then I will also take you like I will also leave you with a take home exercise where like I will be giving you some suggestions and some concept of how you can actually make a home surveillance system using face recognition. Okay, so in the coding examples we will see about like various things that you should be doing. And if you guys have your laptop with you, I would suggest that you guys can try with me when I will be doing the coding. Okay, so I will be trying to do it at a reasonable pace so that you guys can code with me. Okay, so let's just see. So what you should know like before attending this lecture is that you should have basic programming experience in Python. And I think in the first session of the workshop we saw like like a detailed like explanations of Python concepts. Okay, tools that we'll be using in this lecture is Google Colab. I think Ayushi and Akshay has like given you sufficient exposure about Google Colab, and you know how to work in Colab. And we will be using daily machine learning library, like which is like which actually uses a like a set of tools of like in machine learning to code face recognition algorithms. And its installation is very easy. You just do pip install face recognition, and it will do all the things. Okay, so now like in the first part of this presentation we will have some introduction to machine learning. I will start from like basics, and then we will have a like a high level introduction to the various concepts, and then we will do live coding. Okay, so I will spend a less time on the theory, and I will spend more time on the coding and other parts of the presentation. Okay, so in the typical machine learning system, as you must have seen like in the second session in the classification, where what we have is we actually have several parts where we first give like an input to the machine learning system, and then like there is a domain expert which actually do feature extraction. So for example, it identify useful features of this particular input, right? So for example, this is a car. Here the useful features could be the size of the car, the weight of the car, the size of its wheels, and the shape of the bonnet, and all other things. Okay, and then we actually like train a classifier, and like so for example the classifier could be SVM, which actually do a binary class classification of predicting whether the features belong to a car or not a car. Okay, so let's just see like some details of the binary classification, where let's say if you are talking about cat versus dog classification that you have seen in the second session of the workshop, where uh, like like we showed how you can actually create a binary classifier using neural networks to to do the classification. Another example we saw in the second session, and it was your take-home exercise where how is it that you can actually do the classification between faces with mask and faces without mask. Okay, and so for example, an image contains a face or it doesn't have a face. Okay, so this is an example of binary classification, and there are many more examples, and I hope you guys must have tried after the second session of the workshop. Okay, so how we implement binary classification using machine learning is it actually has two steps. One is feature extraction, another is classification. In the feature extraction, uh, we extract the features. Features are nothing but the individual measurable property or characteristics of the input data. So as I've given you example of the car, the features of the car could be the individual measurable property or characteristics of the car. Classification is the process of categorizing a given set of data into classes categories. And nowadays, instead of the traditional machine learning, we use deep learning, and where you use neural networks. We directly give the input image as the input to the neural network, and then it performs the feature extraction on its own using convolutional neural networks, and the classification using fully connected layers or some other paradigm can also be used, and then it actually gives you the output of whether it's a car or not a car. Okay, so here the traditional or the new systems of machine learning, basically like how they work. You actually have the input data, okay, and you also know the labels of the input data, and you train your learning system, and then you get that correct output. Okay, or if it's a wrong output, you will tell the system that that it's a wrong output using the ground truth, and then it adapts its learning. If it's a SVM, it adapts its hyperplane or the maximum margin, and if it's a neural network, it actually updates its weights. Okay, so I hope you guys are aware about it because we had a session on it. Okay, now once the training is done, we have the testing set. We take a new data sample, and then we give it to the learned system that we trained here, and then it provides its best guess of the input data. So for example, whether like the image that we are giving here, it will say that okay, whether it's a car or not a car. Okay, or if we are giving like input image as maybe bike, it will say bike or not a bike. If we give a image of the face, it will say whether the face has mask on or not. Okay, so the crux of this slide is basically two steps, where in the first step we learn during the training phase, and the second stage is we are using the learning using during the testing phase. I hope you guys are aware because we are repeating it from the last 3 days. Okay, so now we are why is it that we are using machine learning and deep learning? Because machine learning or deep learning has shown huge advances in doing the classification or control or other tasks, and in several of the tasks, researchers have actually claimed that the models trained using deep learning actually achieve human level performance or more than that. Okay, so we have large amount of data to process, and if we actually try to build some causal models or some logic based statements on this large amount of data, it's very it's kind of impossible because we have so many use cases. Okay, so now we will also need a lot of computing power to process this large amount of data. So that's why now we have easy access to GPUs and TPUs. We can develop a deep learning based model, and we can train this. Okay, and so Amazon, Facebook, Google have access to a large amount of data. For example, Facebook have access to your images. Everyone who is uploading images on the Facebook is actually learning from those images. Google Photos you are uploading, and Amazon also has some something, maybe I think it has some history of customers or history of your purchase behavior. Okay, so based on that, it is able to train a good recommender system. Okay, so these are the few examples, and because of having the large amount of data, they are able to train their systems in a very highly accurate. Okay, so now this was a very basic introduction to machine learning. I didn't go into deep because we already have had a few sessions on it, and now we will directly jump into face recognition. So basically, face recognition is nothing; it's the ability of a machine system to recognize a person's face in the image. So basically, we are teaching computers here how to detect or recognize a face. So, for example, we are giving this image to the machine learning system, and it will say that, okay, so this is the face in the image. Okay, so the bounding box actually says that this is square is the bounding box, and this actually says that okay, so this region has a face in it, and it is also telling the identity of this face, like, so this face belongs to John. Okay, so this is what called as face recognition. That means if I'm giving you the image of a face, it will say whether the face belongs to Anil Sharma or not. Okay, now, there are two important terms here: face detection and face recognition. So, what is the difference between both? So, for example, let's say we have many of these faces in one image. So, face detection will actually say you, okay, so this is the position of face one, face two, face three, face four, face five. Okay, so this is only the detection. Now, face recognition will say that, okay, so this is the position of the face, and this face belongs to Nico. Okay, so this is face recognition. Now, apart from the face recognition, we can also do is like few more things. So, for example, we can identify the gender of the person and the age of the person. Okay, and we can also do emotion recognition. So, for example, okay, so now this face is actually smiling, and the system's confidence in saying that it is smiling as is 96%. Okay, so we can also do emotion recognition here. Okay, so I will tell you a few applications of face recognition, and then I will jump directly into the coding part. Okay, so the application of face recognition is not very recent. It's like used heavily in the systems from a very long time. Okay, so for example, in digital photography, every digital photography you have, like, I think almost nowadays almost every camera you see, whether it's in a mobile phone or in a camera, so you say that, like, so they are able to detect the faces. Okay, so that you can focus on the face and can give you the better quality. So just see, right, so in the weird scenarios where you have lightning on the face, right, so you are not able to see the face properly. So what you can do is you can focus on the face using face detection, and you can get better quality face image from the digital camera. So this is the advantage of these digital cameras, that they are having face detection inbuilt, and they are doing like some maybe dynamic range enhancement or some adaptive focus and like that. Second, like potential application is surveillance. Let's say if I tell you that your university is actually restricting non-authorized access to your campus. So now what they should have is they will actually ask maybe a guard or something, a guard or someone who can actually have surveillance here, and like they will recognize and will see that identity card and other things. Okay, so there are chances that your identity card is at home. So in addition, instead of that, so your university can have a automated system using face recognition, and they can actually detect, okay, this face belongs to this ID, this face belongs to this ID, and this face actually doesn't belong to any ID, and you can block the unauthorized access, like by raising a by raising an alarm or informing a person, or something like that. Okay, tele-education nowadays, work from home or online meetings are highly common, and let's say uh, there also, like, we need to do some attendance or other kind of thing. So maybe in a zoom call you will soon see that, okay, uh, so I can do the face detection, face recognition, and okay, so in my class, like, who among all, who all are present, and uh, so whether a particular student, like, how much time a particular student actually stayed in the meeting, right? So it's very easy to switch off your camera and go away, but using face recognition you can detect okay, whether the person is in front of the call or not, okay, and, or how much fraction of the time he was there in front. There are several other applications, like, so for example, album organization, organize photos by person. Okay, so you are uploading a lot of photos on Facebook. Now Facebook is actually giving you suggestions, or Google Photos is actually giving you some suggestions that, okay, so these are some similar looking faces, and you can actually create a maybe playlist or maybe some album for some particular faces, emotion and expression recognition. Okay, identify number of unique people, like maybe for marketing purpose, and there are several other applications. Okay, so I will not go into the details of every application. Okay, so now what are the tools available for face recognition? One is, like, let's say, for if we say about the commercial applications, which requires sharing the data with the cloud. So for example, a motion recognition API, which is available for face recognition, emotion detection and motion tracking. Okay, so you can actually use these APIs in the cloud, and you can upload your photos and can get the results. Okay, you can also create an application by using this API, and it will do all the things. Okay, Microsoft Azure Face API, where you can do face recognition, age and gender detection, and face similarity matching. Okay, so for example, let's say if I say you say any of one of the student here, if I want to know, or if you want to know who is the similar looking celebrity with your face. Okay, so a Microsoft Azure API can actually do that. It will take your photo, and it will crawl the web, and it will identify which one is the most similar matching photo with your face. Okay, so now there are also open source like APIs available, like, so for example, OpenFace or DLib, that we will be using in this session. Okay, so we'll see what to do with this. Okay, so now in this part of the presentation, we will be talking about face detection. Okay, so face detection is a very simple task where like we are actually detecting the whether a face is there, and if it is there, where it is. Okay, so it is the ability to detect and locate faces in the image. Okay, so we are teaching a computer whether an image contains a face or not. Okay, so how is it that we will be doing? In the computer, we will be having our machine learning system, and this machine learning system will help the computer to actually identify whether the given image has a face or not. Okay, okay, we are not talking about the identity here, we will talk about the identity in the face recognition. Okay, so let's say we are saying that we have a very big image. Okay, so in this image we already have only the face here. So the only decision that the machine learning system has to make is, like, so it can actually identify some similar looking features, like, so there are eyes, there are nose and lips are there, there's some round structure. Okay, so it's a face, right? And if it is a image of a table, it can say it's not a face, right? Those features are not present. But let's say there is a very big image, and the image is actually very small in that. So how is it that we are actually saying, or let's say there are multiple faces present. So what we will be doing is, we will be using a sliding window classifier. We will so basically we will start from this particular image, from the big image, and we'll say, okay, whether it has a face or not, and then we will slide over all the pixels, and then we will identify, okay, this doesn't now. Okay, so we are seeing the features here. So okay, this particular part of the image has the face. Okay, so in the last slide we saw face detection. Now it is a localization. Okay, how is it that we will be locating the face in the image? Okay, so using the sliding window classifier we'll be doing it. Okay, so now we will extract this part, and now, okay, so now we know that, okay, so it has a face. Now we will go with the face recognition. Okay, now common face detectors that we have here are like, traditionally there was a Villa Jones face detector, where we were using traditional machine learning based approaches, and which use decision trees, and it was very, very fast. Okay, but it was uh, like not highly accurate, and it was mostly used for low resource device, for example, earlier mobile phones, or your single board computers like Raspberry Pi. Okay, so but it was low on performance. It has high false positive data. Okay, now the second approach is feature based approach, where we were using hope based features. Now in a few slides we will also see what is hope based feature, and like basically it uses gradient from light to dark regions. We'll see like what it is, and it is slower but accurate. Okay, so we can also use other feature base. So it was not that slow, it was not that accurate. Okay, but it was reasonable. You can also deploy these in the single board computers. Nowadays, neural networks are used. Like, so for example, convolution neural networks, which are highly accurate. These, but there is a limitation that we need a very large amount of data for these algorithms to train, and these also require a dedicated hardware like GPU. These cannot be trained in a single board computer like Raspberry Pi. Okay, so now we will see histogram of oriented gradients. I think for next two slides, you will see a little, uh, what we say, little technical part. Otherwise, I will directly jump to the to do what we say to the coding part. Okay, so please try to understand this histogram of oriented gradients. And if you like have some problem, like ping me and stop me in between, and then I will try to answer your questions. Okay, let me go to the video once, meeting once, and let me see. Okay, if you guys have any query, you guys should let me know and unmute yourself, and I will try to answer your query. Okay. Okay, so now what is a histogram of oriented gradient? It actually counts the occurrences or the histogram of gradient orientations in the image. Okay, so now what is a gradient orientation? So, okay, so in the gradient orientation, what we will do is we will divide the cell into different images, sorry, different cells, and for each cell in the image, we will compute the gradient. So what is a gradient? Gradient is the change in the pixel value from light to dark or dark to light region. Okay, and for each cell, compute histogram of oriented gradients. Okay. Okay, so basically these gradients we have found, and then we will then compute the histogram of these gradients. Okay, so for example, let's say this is a very like small image where these every square is a pixel here. So it's a very small image, and I'm showing you the larger part of like in a larger scale. So that's why it is looking very blurred to you, but actually it's an eye. So let's say I have selected a square here, which is a 1 pixel. Okay, and what we will do is we will identify all the nearby regions. So for example, I have only selected the upper, down, left, and right. And what we will do is from the left to right, what is the change in the pixel value? It is one gradient. Right to left, another gradient. Top to bottom, bottom to top, another 4 gradients. Similarly, instead of that, like I can also choose left, top left, top right, bottom left, bottom right. Okay, so we can have eight pixel values. Okay, so what we will do is once we find the so this arrow actually says the difference in the pixel value from the left to right. So what we will do is for each cell we will actually identify the maximum value from the all the 8 neighbors, and we will plot it like this. Okay, so for this particular pixel, the top right has a maximum value. For this particular value, uh, mm, top pixel has a maximum value. Okay, so these are the orientations. Okay, so now so what we will do is we will actually take the histogram of it, and this will actually come up like this. Okay, so for this particular pixel, the top has the maximum magnitude, the top right has the second, and then the top left has another, and then like that. Okay, so this is the length of the arrow is actually saying you the number of entries that we had for that particular orientation. Okay, so this is one thing. Now, how is it that we will be applying it on the images? Let's say we had this image, we are applying our histogram of oriented gradient on this image, so it will be coming out like this. Okay. Okay, so if we plot the histogram of these values, it will be coming up like this, and this histogram is nothing but our set of features that we will be using for face detection. Okay. Okay, now before going directly to the coding, let's just understand the steps for it. Okay, so in the first step, what we will do is I have also given you the example of a machine learning system where we first collect the training data, and then we extract the features, and then we will training the classify. So what we will do is we will first collect the training data and extract the whole features. So for example, let's say for like many images, we have this one image. We'll say that, okay, so we'll extract the whole features of this. We have extracted whole features of this particular image, like this actually has a face, okay, and there's this, like that. Okay, so we collect so many images, and then we collect the features, or we extract the features, and then we train a face classifier. Okay, so for example, a machine learning system, and then we'll use a sliding window classifier to locate the face. And so in short, we had the image, we extract the hook features, we train the machine learning system, and we will come up with a decision whether it has a face or not. Okay, so for example, this is another image, we'll extract the hook features, machine learning system, it will say that, okay, it doesn't has a face. Okay, now, we will not go into the training of this machine learning system, as you guys have already seen it. We will directly use a pre-trained model. Okay, and I will tell you how you can do that. Okay, so there are a few advantages of Hope features as compared to other features, but I'm not going into the details of it because I'm not talking about other features here. Okay, so but there are some advantages over other features. Okay, so now we will go to the code example in Colab, and I will go with the coding part, and then you guys can also follow with me. Okay, but before that, I would like to have a 1 minute pause, and if you guys have any query, you guys can let me know. Is there any query? Okay, if there are no queries, maybe I will proceed. Oh, sorry, I was on mute. Uh, okay, so now first what we will be doing in Colab is we will be mounting our Google Drive so that we can read images from the drive. Okay, so let me first mount it. Okay, you guys can also try this thing with me. I think I will not go too fast. It's very easy. Okay. Okay, now I will just mount my Google Drive. I think it is not required from your side, but you guys can import. Because I am importing because I have to read a few files from my Google Drive. So okay, so it is mounted. Let me change the directory. Okay, now as I was talking about that, we will be using a face recognition package in Python. So we'll do pip install face recognition. Let me just do it. Every time you like start Colab, you have to do it. Okay, so let me just do. Okay, so it is installed. Now let's just go with the first. We will see how to extract the hook features, and then we'll go into the classifier. So for extracting the hook features, we will be using OpenCV, and like it is actually available in Colab. So you can directly import CV2 here, and then let's say I have an image of Leonardo. I guess you guys know who is Leonardo DiCaprio. Let me see where is Leonardo DiCaprio's image. Okay, so Leonardo. Yeah, this is the. Okay, so this is Leonardo DiCaprio. Okay, I will extract. I will read this image. I will convert it to binary RGB to gray, and then there is a function hog in SK image, and we will actually import that. And as I was talking in the slides, that you could have multiple orientations. So by taking the multiple neighbors, so you can take 4 neighbors or 8 neighbors. So we are taking 8 neighbors here, and pixels per cell, as I was saying, that like we will divide the images into a cell. So we will be choosing a cell of 16 cross 16, and we will create one cross one block out of this 16 cross 16, and then we'll go ahead. Okay, and then we will plot and all this is just plotting. Okay, so let's just try to run it. Okay, okay, so this is just nothing. Okay, so like the image that we are getting from here, we are just like just rescaling it, and then we are plotting the original image in the hog image. Okay, so this is the hog image that we are getting. Just see that this is the original like grayscale image, and just see, right, histogram of oriented gradients have actually removed all other information. Only the face features are actually kept. Okay, okay, so just see the size of the image, right? And there are so many pixels, and hog is also very fast. It gave you like an answer in, I think, 6 seconds. Okay, I think it is less than 6 seconds, because we are doing some plotting and reading as well. I think it is less than 1 second for computing the hoax. Okay. Okay. So now let's just directly go to the face detection part. For this, we will import face recognition. Okay, and we will be using matplotlib to actually plot some rectangles over it. Okay, and then we will be using OpenCV to read the images. Okay. So now let me read the image of, let's say, Leonardo only. Okay. So Leonardo.jpg only. Yeah, JPEG. Okay, so this is the image we will read. We will just convert it to from BGR to RGB. And this is the image that we are working with. Now let's just see how is it that you will detect the faces. Okay, so what we will do is we will first find the location of the face here. So now we already have the pre-trained model. Now how is it that you can use this API to actually locate the face? So face recognition, from the face recognition package, there is a method called face recognition dot face locations. From this image, it will actually identify the location of the faces in this. And then let's just see what it is. Okay, so now if there are multiple faces, it will return you the multiple like from here. Okay, so it says that face recognition is not defined. Okay, I think we have not run this. Okay, now let's run it. Okay, it says that there is one face found in the image. Okay, so now let's just try to plot it. So what I have just done it. So let's say we had only one face. So let's say if we had multiple faces, we have to run multiple. Okay. Maybe before that, let me just go to an image which has more than one face. Maybe let's say this clone Leonardo has two faces, right? Yeah. Let's just first read that. Okay. Now this is the image that we will be using. Now let's say what it says. Okay, it says that there are two faces found in this. Okay, so now let's just plot what is the face location. Okay, so this library actually gives that as well. So for each face, will run a for loop, and this is the face location. Basically, it returns the top, right, bottom, left pixel value. So we'll say that, okay, so this is XYWH, not pixel value, but it is a pixel location. Okay, so now we will make a rectangle out of it, out of this XYWH. Okay, and then we will add a patch to the axis like of this rectangle. Okay, and like we'll do this, and then for the second face also we will do it, and then when the for loop ends, we will plot the image. Okay. Okay, so this gives you the location of the faces in the image. Okay, so I hope you guys are able to understand what I'm saying, right? So I have actually shown you an example how by which you can actually uh, like detect the faces and can also identify where is the face in that particular image. Okay, if you guys are trying along with me, you guys can ask the questions, and if you are facing any error, I will try to help you with. And if you are not trying it, I would suggest that please try after this session. It's very simple. I will share the code, and also if you have any query at this point of time, you guys please let me know. Okay. Okay, I think we are done with this. Now we'll go with the face recognition. Okay, so we show in the code example how is it that you can detect faces and can also locate it. Now let's just go to the face recognition, which is like second part of it. So in the face recognition, we first do the face uh, detection. So that means we'll locate and extract the face from the big image. And for each image, we will actually train another model to say whose face is this. Now the question is how to train that model. Okay. Students, please listen to me carefully. It's a very important concept in AI. How is it that you can train a model to actually recognize whose face is this? What we will be doing is we will be using an encoder decoder architecture. Okay, so what this encoder will do is, this is one model and decoder is another model. So these are basically part of the same model. They are trained like together. Okay, but these are different set of neural networks. Okay, so what this encoder will do first is, so for this image it will take this as input, and it will return an encoding of this particular face. Okay, and then the decoder will take this encoding and it will try to reproduce the same face out of it. Okay, so it like performs this operation for several face images several times, so that uh, like what we can say that, like, so instead of using this face, we can use this encoding that, okay, this is unique to this face, and using this encoding only we can regenerate the face. Okay, so this decoder is actually saying it. So for example, let's say this face is the for the George Clooney. Okay, this is the encoding for the Leonardo DiCaprio. Okay, now we have George Clooney from some other viewpoint. Okay, now let's see, right? So the encoding generated for this face is this. Encoding generated for this face is like highly different from the first one, and the third face has some similarity with the first face. Okay, the encoding is actually similar. So the encoder should actually should be able to say that like the input image that you are giving. Okay, I can produce some encoding of it which is unique to that particular face. Okay, so the first and third has some unique features, or it belongs to the same person, so the encoding has a very high similarity as compared to the first and second and third. Okay, so second is from the some different person. Okay, now these encodings are actually dummy like encoding, just to give you some explanation of the concept. Okay, and we will not train the encoder and decoder here, we will use a pre-trained encoder. Okay, so now in the third step of the face recognition, we will compare the faces with the known faces. So for example, firstly we will make a database of the images. Okay, so I'm giving you an example of the three faces, a database with three faces only, but you actually need to make a database with very large number of faces. Okay. So what you will do is, then in the first step of like using this data set, like we will create the face encodings for each of the face. Sorry, encodings for each of the face. And like, so for example, for this, the first one is this is the encoding. Just look at my pointer. And for George Clooney we have this. Oh, sorry, Leonardo DiCaprio we have this. For Clooney we have this. Okay. Now what we have is, in our database we had the three images that I'm showing you in the slides. And then now we will get a new test image which is different from the images from the data set. Okay, what we will do is we will also compute the encoding for the new test image. Okay, now in the next step we'll compute the distance to all these images. Distance means Euclidean distance, or like some other distance like cosine similarity and others, which will actually say that how similar this encoding with this particular encoding. Okay, similarly we will match the encoding of this test image with all the encodings that we have on the database. Okay, so after computing the Euclidean distance, so for example, what we will do is we will compute the Euclidean distance using this particular equation as I'm showing you on the slide, and then we will apply a threshold. So for example, if the face is, if the distance is actually coming less than 0.6, we say that like it's a match, otherwise it's not a match. Okay, so the so I have actually computed the Euclidean distance from the of the test image from the images in the database. The distance is coming out to be 0.95, 0.85, and with this, with the third image, the distance is coming out to be 0.39, which is less than 0.6. So we'll say that this test image that I'm showing you on the slide is matching with the third image in the database, which belongs to George Clooney. So we can claim that the test image is the George Clooney's image. Okay, so this is how the face recognition actually works, and it is a very small 4-step process. Okay, so we have seen example here. Now we will go to the Colab, and we will see the example. How is it that you can do the coding for this? Okay. Now we have seen the face detection. Now we will go to the face recognition. Okay. So I have this image. Let's say we will read the same image as I was showing you in the slides. Okay, or let me also plot it. Okay, so this is the image, or maybe I think face recognition is a little down. Yeah, face recognition is here. We will what we will do is in the face recognition, the first step was to actually create a database. So what we will do is we will first create a database, and we will, let's say, uh, I have these three images: face demo, clone one, and Leonardo JPEG. Okay, so the face demo image, Clooney one is this, and Leonardo DiCaprio is this. Okay, so these are the three images that as I was showing you on the slide, right? Only with these three images, I am creating a database. Okay, I have read these images, converted this from BGR to RGB, and what I will do is I will first compute the face encodings. Okay, these face encodings I have I have computed using face recognition dot face encoding. This is a function, and like the image that we want to compute the encoding, we are giving the input, and then why I'm putting 0 here, because there is a chance that there could be multiple faces in the image, but for creation of the database, we are ensuring that there is only one image here. So we are only taking the first one of it. Okay, so if there are multiple images, I think we can use it, but we need to actually use both the faces separately and create the database. So the database that we have created is non-face encodings, is actually the three encodings that we are showing in the slides. Okay, so these three encodings. Let me run it. Okay, it's running. Okay, now what we will do is our database is created. Okay, so our database is created. Our encodings are also done. Now we will read a test image and then we will compute the encoding of it. Let's say I read note the clone 2, like which is similar to this one. Let me read the an image which contains the multiple faces from the database. Okay, clone Leonardo I am reading. We'll convert it from BGR to RGB, and now let me just show it. Okay, so there are two faces. Okay, now this is the unknown face image we have read, which has multiple faces. We have to compute the encoding for it as well. Okay, so let's just run. Okay, so now we will actually use face recognition dot face encodings, and from this unknown image. Okay, and we will compute the face encodings for it. I'm not applying zero here because I want to use face encoding of all the images that are there in this unknown image. Okay, now for all the encodings, let's say if there are multiple faces, there will be multiple encodings here. So we will actually run a for loop for it, and then we will actually compute the equivalent distance. So for example, uh, for all the images in the database, so known face encodings that we had, which is the name of our database, and for this we will run a for loop, and we will actually compute an equivalent distance between our known face encoding, that is which is one of the encoding in the database, and unknown face encoding, and then we'll compute an equivalent distance and we'll store it in this results variable, and then we set the threshold at 0.6, and if the threshold is actually less than uh, this one, this result, uh, the value that we will set it true, otherwise it will be false. Okay, and if the result is true for the zeroth index, we'll say that okay, it's a face demo image. If it's true for first location, it is George Clooney, otherwise it is Leonardo DiCaprio. So let's just say what it says. Okay, in the first face image, it says that Leonardo DiCaprio is in the photo. In the second face in the photo, it says that George Clooney is. Okay, so now let me read some other image. Let's say we read this woman's image. Okay, so what's the name of this woman.jpg? So let's say if the image is not there in the, okay, so this is the image that we are reading. Now let's say what this particular says. Okay, found unknown in the photo. Okay, so that means that particular face is not in our database. Okay, so we'll see an exciting application of face recognition at the end of this session. So we'll see how is it that we can do. Okay, so this is how you do face recognition. You can actually identify if a particular face belongs to like some of the known faces that you know. Okay, we have seen an example in Google Colab. I hope you guys are understanding it. If there is any query, please let me know. I will be happy to answer it. If there is any query, please let me know. I will be happy to answer it. Is there any query? Okay, I hope there is no query. Maybe now we will see one more application of face recognition. But now I would like to take you to some other interesting application where, let's say, if you are using Instagram, Snapchat, Share Chat, or something else, you must be curious. How is it that they are actually giving you some different face filters and they are playing with your face photos? How to do that? Now, there is a technology called facial landmarks. You actually identify the facial landmarks, and then you can put or you can actually do a lot of things with your face image. Okay, so now the facial landmark model that we will be seeing is a 68 point face landmark model. Okay, which is also available in our library, face recognition. Okay, so what this face landmark model is, it will actually take your face image and it will give you the location of everything, like the location of the eyebrows, eye, eyeball, nose tip, nose, lip, upper lip, lower lip, chin structure, and some of the landmarks can also give you the ears and the and your forehead as well. Okay, so but we will be seeing a 68-point face landmark model which only gives these images. Okay, so using this particular face landmark model, what you can do is you can do several. So what you can actually do is you can do several exciting things. So for example, you can put like lipstick or change the color of the lipstick. You can actually put lenses, you can put necklace, you can put a hat or earrings. Okay, whatever you want to do, right? You can do that. So you guys must be seeing that in the Instagram, or maybe I'm not sure like which application it is. You can also change your face and look like it a horse, right? How to do it? Just access your face landmarks and access the face landmarks of a horse and just change it. Okay, in between your chin structure, put the face of the horse. It will be like that. Okay, so it's very simple technology. It's not a very hard and fast rule. Okay, using facial landmarks, you can do that. Okay, so this is the facial landmark structure. Okay, now there is one question. Okay, I hope you guys are understanding it, but I was expecting this question from you. Now, this particular image, please see my slider. If the video is a little delayed, the second image is from the slide where we have the face landmarks on in the red color. I'm pointing to it, and this image is a little tilted, right? It's not the front face. So but the face landmarks is actually computed from the front face. How is it that you actually compute the face landmarks and map it to this and then apply the filters? Okay, basically there is a fine formation that you can do, and you can actually tilt your face using that transformation, and that is also simple, but we'll not go into that. We will just assume that we know it. Okay, okay, so now let me just give you the example of that. Okay, how is it that you can make changes to your. Okay, so now let me read an image. Okay, so which image should I read? Maybe let's say face demo we should read. Face demo.png. Okay, okay, so this is the image I'm reading. Okay, now first, let's say first we will extract the face landmarks. How will we do is from the face recognition package, we will be extracting the face landmarks. And if there are multiple faces, it will give you the landmarks for the multiple faces as well. But we have only one face, so we will only have it. Okay, so now we will just show what are the landmarks. Okay, please give me. Okay, so just see right what this face landmark is. Okay, so now, like before going to it, let me just give you some introduction to the face landmarks. Okay, so let's say this is the image that we are reading. Okay, from face. So if we read it, okay, so from face landmarks, it will give you the face landmark list. Okay, and you can also count the number of faces using it. Okay, so I will not go into the details of this for loop, but it actually plots all the face landmarks. Okay, and it is how you will get the face landmark. So what it is giving you is it is giving you the pixel locations of your left eyebrow, chin. Just see the selected part. Okay, right eyebrow, nose bridge, nose tip, left eye, right eye. Okay, so all these information are given by this 68-point face landmark. Okay, so I think these are just the pixel locations, and we have plotted these on the face. So now, okay, so this is the image that we have read, and now you guys have seen that. Okay, so these are very like easy lips, and you must have seen like, now let's just say like, so this guy has open face. Now let's see, we just want to apply some lipstick to it. Okay, so let's just see how to do it. Okay, from the face landmarks we'll run a for loop. Okay, so what we will do is we will access the left eyebrow and right eyebrow, and we will plot the lines on it. Okay, and what we will do is we will also on the top lip and bottom lip, we will actually fill the face color using light salmon color and the edge color using orange. Okay, so let's just see, let's just run it, how this will look like. Oh man. Okay, so this is how okay, so this is how it will look like. So we have actually applied the lipstick. I think I'm very bad with the art, so I could have only these colors. But you guys can play with the colors and see like how these things will actually look like. Okay, I hope you guys are liking this example. I am just giving you the real life examples, and you guys should be able to apply it in uh, your own code, and you can see like how is it that you can use face recognition and create a like a create a create a few nice applications. So now I would like to actually show you whether this thing works with multiple faces or not. Okay, let's just see if it works with this. What is the name of the image? Okay, this is the image. Compute the face landmarks, the landmark of the left eye. Okay, so okay, zeroth, and there are two facial landmarks. So the left eye locations are different for both of the landmarks. And let's say just plot the same thing for these two faces. Okay, so this thing is working very nicely. Like, so this, see, right, this is highly accurate. So on both of faces, this lipstick is very accurate. Okay, I hope you guys are liking these examples. I try to make it highly real, and you can just pick one of your friend's face and apply some of the artifacts on it. So you can do several things, right? So you have location of the various face landmarks, and you can make a lot of changes. Like, okay, I will give you an example, a homework here. If I ask you to apply a specs here, how is it that you will be doing? Okay, so please try it on your own and see how you can apply a specs. Or one of the real example, let's say in the session 2, Ayushi has actually given you a very nice take home exercise of detecting marks, a face with mask and face without mask. Okay, and she must have suggested you to actually generate like a data set which has the which puts the if mask on the face image. So how is it that you will do it? Okay, so this will be your another exercise. I think now you know how is it that you can put the mask on the face, identify the landmarks, and put the mask over it. Okay, but actually you don't need a facial landmark, as Ayushi must have told you, but you can use it. Okay, okay, so it's like putting a mask on the face is very easy in the code, but like this will be an exercise for you. Okay, so if you guys have any query, you can ask us. So this is just a like you can say the take home exercise. But along with that, I will give you a very interesting application for your exercise, for your take home exercise, or homework, you can say. You can build a smart home surveillance system. Okay, how is it that you will do is, let's say you have the Raspberry Pi and a Pi camera. So this is this the single board computer that you are seeing in the image is a Raspberry Pi. The On this mold, there is a camera which is known as Pi camera, and you can actually purchase a cover for it, and it will look like this. Okay, you can put it at different locations at your home, and it will look like a CCTV camera, and it is actually without wires. It will work with Wi-Fi. Okay, so how you can set up the Raspberry Pi without any extra hardware? So just I would suggest to go with this link on Instructable, and it will tell you all the details. How you can install face recognition API on Raspberry Pi, these are the details. You can go to the authors page, and the details are there. Now using OpenCV, you can access the camera live. We have used OpenCV in this session to actually like read the images, but you can also do it by using the like like by accessing the live feed. Okay, and you can use the lecture or this session to perform the face recognition. Okay, so just have the live feed, just extract the uh, images from it, and then see whether you can do a face recognition or not. So for example, let's say you have 5 members at your home, create a database of those 5 members, the different face images of those 5 members, extract encodings, and then create a database. And whatever new faces you are seeing in your pi camera, just see whether the face belongs to your uh, database or not. If not, you can also write another script to actually raise an alarm or push notification to your phone using Raspberry Pi. Okay, so how to send the push notifications to your Raspberry Pi? Just follow this particular link, and this will, believe me, if you work on this for 2-3 days, it will be your application, and you can create a real-time CCTV camera which works on which also has face recognition. Okay, so this is an example for you, and I think I am done with the today's lecture. I think we have completed 10 minutes or 15 minutes ahead, but I wanted to had a discussion with you people, if you guys are liking the sessions or like something on the feedback. And so Sabya, are you there? Can you share the feedback with the students? Okay, so meanwhile, you are receiving your feedback form. Can you guys tell me if you have any queries or any suggestions or anything that you want to share with me, right? In face recognition or some other lecture also. Any query, any of you on face recognition? I think I have given you several coding examples, and you must be having some query or any thoughts, like how is it that you can actually improve this particular part. Okay, now in the chat box you have the feedback at attendance link. Please fill it up, and if you have any queries for the workshop, for the session, please let us know. Any questions you have? I think this is the fourth day of the workshop. I am expecting that you must be having some question. Okay, let me ask you a question if you guys don't have a question. Okay, sir, how does face recognition work when a person is wearing glasses? Okay, this is a very good question, Srigri. Uh, so, in the face recognition, we are actually computing the features of the face, right? So, let's say if I have the glasses on, right? Ideally, what I should have is in my database, I should have my image with glasses, without glasses, or like with various angles as well, so that my all the features are computed are captured, or my all the encodings are captured. Okay, so that when we have a new image, we can compare with all of them and see whether it matches with the same person or not. Okay, but to answer your specific question, how this will work with the glasses, because because like, so with the glasses or without the glasses, your feature stays the same. Okay, so if I'm saying about my chin structure, if I have the glass on or not, the chin structure will stay the same. So the face recognition will surely work even if you have glasses on or not. Okay, I hope I have answered your question, Srigri. Any other question you guys have? Okay, or let me ask you one question. Uh, like, what exciting thing do you want to do with AI? So, do you know that AI, like, let's say if you are a normal developer, normal computer science coding guy, uh, okay, in face recognition, does it check for your retina? No, it doesn't. Like, retina is another biometric. Face recognition is a different thing. It doesn't have any relation with the retina. Okay, so my question is, how you guys see like AI, right? So, for example, like if you like get a coding job after your BTech, so then you will get a very nominal package like 4-5 lakh. But do you guys know that in AI, the average package starts from 18 lakh per annum, right? So it's a very good thing. and most of the guys are like, so like if you are very good in AI, if you have done several projects, your initial package as a fresher could be 30 to 40 lakhs as well. Okay, so this is a very exciting field, and tomorrow in the tomorrow session I will be actually telling you what companies are looking when they are actually talking about AI, and we will also be giving you certificates tomorrow. Please be there. Please fill your attendance. If your attendance is low, we will not be able to give you this certificates. Okay, and if you are not attempting the quiz also, we will not be able to give you the certificate. Okay. Srigiri also has another question. How does face recognition work if a person is wearing mask or glasses? Yeah, this will work nice, right? So it's the same as the first question, because your face feature stays the same, so it will stay the same. Okay, so the face recognition will work as is. Okay, if you have mask on, so then your most of the features are actually hidden, so it will not work. But nowadays people are actually working on face recognition when you have mask on, so that you can actually identify your face features when your mask is also on. Okay, I hope I have answered your questions, Srigiri. You are asking very good questions. Like there is an obstacle in between to identify, right? Yeah. So with the face now, like most of the face recognition applications doesn't work because most of your features are hidden. Your lip structure, your nose structure, your chin structure is hidden, right? So the face recognition actually doesn't work with mask, but you can also train it. Thanks, Shrigiri, for your questions. I think I'm enjoying your questions. Like I like answering questions. If you guys if have more questions, please ask. Thank you, Shrigiri. Okay, so tomorrow we will be seeing a lot of applications of AI. And another question from Kishore: how will it identifies the each and every location in the face? If we turn face like it's in motion. I'm not actually getting this question. Okay, let me read. How will it identify the each and every location in the face if we turn the face like it is? Yeah. So this particular thing we have seen in the slide, right? So sliding window classifier. So when it's a big image, you slide a window and you actually go with every location in the image and just see okay whether that particular location has a face or not. That's how the face localization works. Okay. So I'm just stopping screen share. Okay, how it works if it is a blind person? Oh, blind person also like so. The structure of the face remains same, right? So face recognition will work. Sir, can we combine two face encodings to create a new face? Is there any specific method to create it? Oh, that's a very good question, Vamsi. I think yesterday you must have seen GANs, right? Vamsi, like we will be having a summer training program where we will be actually talking about all these things. So I think your question is like, so let's say you have a face image, and if I give you spectacles, like so, one image is of your face, another image is of spectacles image. Okay, so if you can combine those encodings, you can't generate new face using the method that I shown you in the slides, but using GANs you can surely generate. Okay, so I think we will be having a summer training like on this, where we will be showing you how you can generate a new face when you have different structures. Like so for example, I have your image, Vamsi, let's say. Okay, I give you this your image to the GANs, generative adversarial network, and the image of a specs. It will return your image with glass on. Or let's say if I give your image and the image when I have a specific hairstyle. Okay, so it will generate a new image of yours where your image will be there and your hairstyle has changed. Okay, so this is a very interesting application of GANs, and we'll be showing that in the summer training. I think yesterday we were not sure like how much you are aware about GANs, so we did some simple things, but we will also be doing some these hard things, the advanced concepts of AI in the summer training. So thank you, Vamsi, for the question. Sir, when it comes to recognizing a face in low light, do we need any extra feature which are supposed to be added? I think this is a specific question on the dynamic range enhancement in the images. So if you can actually do histogram equalization, it may work, but you may need some specific lightning or maybe some specific filters to be applied in the image before applying the face recognition. Because if it's a low lightning condition, your like uh, image pixel values change, so the encoding values also change, so it may actually create some problem in your face recognition. Okay. Yeah, it depends on the algorithm that you use. So if it can capture face in low light, it depends, right? So so if it is able to capture the features of the face, it will say, it will detect the face and localize it. If it can't detect features, then it will not, right? So because low lightning actually impacts the face detection and face recognition. uh, so so you need to be careful, so if you can actually apply some filter on the in the image, then it will surely work. Depends, Shrigiri. It depends if the low lightning, how severe it is. If it is highly severe, it will not work directly. You need to apply some filters before applying face detection or face recognition. Okay, any other question? Yeah, thanks. Thank you, Shrigri. You had many questions. Thank you, Vamsi. Thank you, Rahul, for your question. Thank you, Kishore. You asked very good questions. And let's say an actor has undergone several surgeries, then it will work the same. No, the features of the face has changed, so it will not work. But it is a topic of research. Like many researchers are actually working on it. Can you actually identify a terrorist if it has actually done some plastic surgery? Okay, so there is a I think yesterday was a lecture from Akshay. His lab was actually doing it. Okay, so it's a very interesting. So actually it will not, but there are some specific works which actually try to identify. So I hope I could say something on this. Okay, can you please share the code? Yes, we'll share the code on the Google group, and you guys please try and please ask questions. If you will not ask questions, you will not understand it. Please try it. Please see if you are able to do. If you are not able to do, please come to us. We can't spoon feed every student. So the more you will ask, the more you will say that, okay, I have tried this, I am facing this problem. We will also see, okay, you are interested, and we will try to offer you some internship. Otherwise it will be difficult for us as well. And try to ask as many questions as you can, and try we'll share the code on Google group, and you guys can try. And tomorrow I will be telling you about a few more applications of AI, and how you can get a job in AI market. Okay, so stay tuned for tomorrow. I think if you guys have more questions, please ask on the group, and we will be happy to answer it. But for today, I think we can wrap it here, and we can meet tomorrow again. Tomorrow is the final day. Please do attend the quiz. It is mandatory to get the certificate. Okay. We'll also make an announcement in the group. Uh, and please try the code that we will be sharing. Um, and if you face any problem, please let us know. Yeah, and please fill the feedback for the attendance. Low attendance may impact your certificate. Okay, I think I'm done for today. If you guys have any query, just I think it's the same. I've answered this right. In the dark means it has low lightning. In low lightning face features, the pixel values actually change a lot, so the feature values may also change, and the face detection performance may impact. And what you can do is you don't have to actually do anything. You just do pre-processing, like do histogram equalization or dynamic range enhancement. If you can do that, the face features will be captured, and your algorithm will work fine. Okay, I think I can take more questions on the group. and we can finish it here. Or yeah, stay tuned for tomorrow. Thank you for attending today's session. Okay, Siddhartha, can we change our face by just using face landmarks? Yes, yes, yes. Oh, I forgot to tell you about this. Uh, so basically, using the face landmarks, you can actually swap the faces as well. Okay, I thought I actually forgot. I had this code that, like, how is it that you can change the faces using the landmarks? You can surely do, Siddharth. Thank you for your question. Okay, maybe sometime next we will show you how you can swap the faces. Okay, since you know about the landmark model, you can do it on your own, right? So just identify the location, scale the new face as per your face, and then put it on. It will work. I think I've given an example of horse, but you can do face swap as well. Okay, I think let's just take questions on group, and please do attend tomorrow. And like, we will see about job market in AI and some applications as well. Okay, see you. Bye bye.